Morning, guys. We're going to be tackling the 2024 Bc Frqs. We're going to start with number 2, and we'll see if we have time for the rest. Okay. All right. So we have a particle moving along the curve in the xy plane. Okay. I can see that we're given x prime, we're given y prime, and we're also given the position of the particle at 2 seconds. So this is going to be our initial condition. Find the speed of the particle at t is equal to 2. Show out the setup for your calculations. All right, let's go ahead and get started. So the speed of the particle, well, that's just given by the square root of x prime of t squared plus y prime of t squared. And because we're already given those, we're just going to go ahead and partially set it up. We're going to say x prime of 2 plus y prime of 2. And just carefully plug it into your calculator. This is going to give us 12.305 is the speed of the particle. At t equals 2. Okay. Nice and easy, right? Pretty easy start. Very accessible. Part B. Find the total distance traveled by the particle from 0 to 2. Okay, so total distance is actually very similar to speed. Total distance. That's going to be the integral from a to b. So in this case, from 0 to 2. And we're going to be integrating basically speed in a way. So x prime of t squared plus y prime of t squared. Oh, I forgot a parentheses. dt. Again, carefully plug it into your calculator, and you should be getting 15.902. Do we have any units? Let's see. We have seconds, but I don't think we have units for position. So I'll just say is the total distance traveled during the first 2 seconds. Okay. I would be talking about the points that you would be getting awarded here, guys, but I didn't write it down. So, but either way, right? These two first parts, they're not so bad. You should be getting both of those. Part C. Find the y coordinate of the position of the particle at t is equal to 0. Okay. Well, for that, we also kind of have to know our initial condition, right? So we already know that at 2 seconds, the position of the y part of the y coordinate is going to be 6. So if I want to find the position of the particle of the y coordinate, it's going to be the integral. Okay, once again, my initial condition was that at 2 seconds, the particle is at 6. So I'll just put a plus 6 back here. Oh, and you know what? Let me put y of 0 because we want to find the position of the particle at 0. Okay, so now we have y prime of t dt. You know, you don't have to write the actual equation, just set it up. And because we're doing this with the calculator, you can just plug it in the way it is. You don't have to flip your integral. The position is going to be negative 1.174. Is the y coordinate at t is equal to 0. Okay, nice, we're doing good. Part D. From 2 to 8, the particle remains in the first quadrant. Okay. Find all times t on the interval from 2 to 8 when the particle is moving towards the x-axis. All right, well, if they're telling us that the particle is remaining in the first quadrant, we don't know what it's doing, right? But I'm just going to make up something, right? Let's say the particle is just kind of like hanging around, moving towards the x-axis, moving away from the x-axis, moving towards, moving away, and so on. I don't know what it does, right? But basically, when you're moving towards the x-axis, we have that downward movement, which means that y prime needs to be negative. Y prime, not x prime. X prime doesn't affect whether we're moving towards the x-axis or not. So, part D, you should graph y primes, see what it looks like. Graph y prime. You're basically going to be setting it equal to 0 to find your critical points. And the critical point, I'll tell you right now, that's going to happen at 5.222. And, well, I just kind of, I don't know if the graph looks like this, but I'm just going to make up a sketch, right? You're going to see your own graph. But it's going to be, the first section is going to be above the x-axis. The second one's going to be below, and that's the part that we want. We want this chunk right here. We want y prime to be negative. So you're going to say the particle moves towards the x-axis when y prime of t is less than 0. And that happens from 5.222 all the way to 8. And that covers all of question number 2. Okay. We'll stop it right here. I'll do questions 5 and 6 later. All right. See you on the next one.